Welcome to update 2 in my series on building your own AI. In the last video I covered the high-level architecture that I was considering building for my solution. Now that I'm actually building, the first thing I want to test is how well the distributed architecture will work. I want to move heavy processing like image recognition to our central brain, but if passing images and messages back and forth via the message queue is too slow, then the design will not work. As I was beginning to install RabbitMQ, I realized it probably made sense to deploy the central components as Docker images, especially the message queue. Docker is something you can research yourself, but basically Docker lets you create or leverage pre-built virtual images that are very lightweight. Our message queue will be just a service that other components will interact with over an IP and a port number. So let's use a pre-built Docker image and we can treat it like a black box that just works. Note that you don't have to use Docker. You can install RabbitMQ directly on your device. I just won't be providing instructions. You can, however, use the test scripts that I show here to test your local install of RabbitMQ. To run a Docker container, you first need to install Docker. I will be giving instructions for an Ubuntu Linux machine, but you can adapt these as necessary for Windows if that's what you're using. So firstly, you should update your apt repository and then run sudo apt install docker.io. Then run the commands to start the Docker service and add it to the system boot up process. Then you can run this command to check on the status of Docker. You should see something like the following. Take note of any warnings that might be displayed and of course any errors. You may see some warning messages like those displayed here. After searching about on the web, I found some indications that these could be resolved by updating the Linux kernel, but the instructions were a bit vague, so I kept searching and then found a tutorial that showed these messages but then pretty much ignored them. That tutorial suggested building the Hello World Docker image as a test using this command. After running that, you should get a lengthy response from Docker that I've summarized here, so as I saw that, it seems my system is working despite the warnings, so let's move on. To enable yourself to run Docker commands without having to use sudo, which stands for super user do, then use these commands to create a Docker security group and add your current user. If you then log out and log back in, you should be okay to run the Docker commands without sudo from there on. We are going to need to run RabbitMQ in a Docker image that is visible on the network. To do that, we have to assign it an IP address. And we'll need to know a free or available IP address on the network. You can use this command to install the Linux networking tools on your PC and then run ifconfig to find out your network connection details. Mine was called WLP2SO and was connected to 192.168.0.108. I've already configured my wireless LAN DHCP to use addresses from 100 upwards, so I know that anything below that will be free. So I'm going to use 192.168.0.50. We then run the IP address add command to allocate the chosen IP address to our current wireless network connection ID. Then we can alias our Docker image to that IP whenever we start it. In the final command, you can see we use docker run to start a Docker container for RabbitMQ. I've referenced a base image for RabbitMQ that exists in the Docker repository on the internet. If the base Docker image has not been downloaded, Docker will automatically download that image and then start our container. The name of the container will be robot AI-Q. Note how we've aliased the IP addresses to 192.168.50, and we've also aliased port numbers. I'm using 8080 to get to the management user interface, which is normally exposed on 15672, but I'm using the same port number as Docker exposes the queue itself on. After the docker run command has finished, your container should be up and running. You can then access RabbitMQ console from any browser on the network using the IP you assigned and the port that you aliased. The default identity available will be guest with a password of guest. Next, we will test the message queue with some Python scripts. Ensure you actually have Python installed and note that all my code will be based on Python 3. Also ensure you have a recent version of pip installed, which is a utility for installing Python libraries. Here is the command to install it if it's missing. You can probably add the upgrade tag to this if you need to upgrade it. To connect to RabbitMQ using Python, we're going to leverage a Python library called Pika. Run the second command here to install it. Next, using a text editor, create a file containing the following Python code. This first script is used to start listening to a queue called hello. Ensure you replace the IP address with your server IP and the same with your port. Save this file as test_listen.py. These files will be available in the link in the comments of this video on YouTube. Then if you open a terminal window, you can run the file that you saved with the command shown here. Hopefully it connects successfully, but if not, you'll need to debug any error messages that are shown. Python is quite good with error messages, and Google is your friend to help you resolve them. Then, using a text editor, create a second file with this Python code shown here and save it as test_send.py. This code will connect to the queue and then send a message to the hello channel. Ensure you edit the server name and port as before. Open a second terminal window and run the file that you saved with the command here. Check your first terminal window and you should see the hello world message displayed. Hooray! You've now got your message queue working. Now that we have our Docker container created, these are the two commands that we need to run anytime that you restart the PC. The first command will reassign the IP address to our PC, and the second command will start the Docker container, which has all of the port and IP address configurations that we created it with. So this wasn't perhaps the most interesting installment, but we are now prepared to test our message queue and start building our AI logic in the next video. Remember, if you want to receive notification of updates and new videos, then please subscribe to this channel. Thank you for watching.